Okay, Chapter 6, page 122, E17A. A 300-gram mass lying on a frictionless table is attached to a horizontal spring with a spring constant of 50 Newton meters. Okay, so you have 300-gram mass, there's a spring, and it's on a table. And the spring is stretched a distance of 0.46 meters. So you have this, and you've pulled it. So now the spring, if you pull it too far, you're going to deform the spring. That's true of any spring. So you're pulling it within the usable distance of the spring. You've pulled it to the maximum, and you're sitting there. So now there's no movement. So it's all potential energy. So part A, what is the initial potential energy of the system? Let's go ahead and do that. So you have 300 grams is your initial mass. And just for reference, that is equal to 0.3 kilograms, right? You got to keep your units. If you're using meters, then you got to use kilograms, right? If you're using grams, that's a whole other system. And we've been sticking with the one, okay? The spring constant is equal to 500 Newton meters, and the distance x that you've pulled the string is equal to 0.46 meters. So what's the potential energy? Well, we know that potential energy is equal to 1/2 the spring constant times the distance that it's going through squared. So that equals 1/2 500 Newton meters times 0.46 meters squared. Okay? Equals, so it's 500 times 0.6 divided by 2 is equal to 52.9. Now your units, you have meters squared, so right, meters, it's squared, so you have meters squared, so you can cancel that squared with this meters, and you still have 1 meter left in the numerator. So your unit is Newton meters, and that's the same as 52.9 joules. Okay, 52.9 joules. All right, part B. What is the kinetic energy of the system when the mass returns to the equilibrium position? So that means when the spring is in its middle resting position, right? So here, when you pull the spring, as far as it's going to go, it's all potential energy. It's not moving. It's just sitting there waiting. You let go, and it's a frictionless table. It's going to go back and forth, back and forth. Well, right in the middle, right? That is the place where it's going to be its equilibrium position. The position where if you didn't pull on a spring, it's just sitting there. That position. So right there at that position, it's all kinetic energy. Okay, when you pull it all the way to one side, it's all potential energy. Then as it's going, it's going to move faster. Right here, it's moving the fastest. Then as it's going this way, well, now it's slowing down because the spring is being stretched again. So the kinetic energy is being transferred to potential energy. Right in the middle is the kinetic energy. Well, the kinetic energy in the middle, so this is B, is the same as your potential energy. So the answer is 52.9 joules for B. Do we have that? And there we go.